let's go ahead and dial in to our first word problem of the day. So, for those of you who have been here before, my party people, quick question. What do we do with all word problems? What's the very first thing that we do? Now, as always, in the live class, we see a ton of folks using the three same letters, RTQ, RTQ, RTQ. Now, the people that are a little more forgiving will go ahead and spell it out, and it means read the question. That's what RTQ stands for. That's the first thing we want to do. Not read the entire problem. This is the whole problem. We mean the question sentence. So in this case, we don't have an actual question, but we have a demand. We have a command here saying, express this length in feet and inches. Let me go ahead and highlight that right there. Boom. So before we even get started, everybody, does it make total sense that the goal here is whatever the heck we're going to read up here, we need to turn that into feet and inches. And if you look at the answer choices, it kind of supports that too. We have feet and inches. Feet and inches. Yeah, do we agree or not there? Right on, and we should. Now, once we have that, once we know what the question is actually about, what we're actually trying to solve for, then the next thing is, let's take down the information. Let's understand what's important, what's not, and we can only do that by just going through the story. But we know what the goal is. We want feet and inches. So here's the story here. Sarah is making a banner for the school dance. The length of the banner measures 83 inches. Okay. Everybody, quick question. Quick question. It says 83 inches. Is that already in feet and inches? Is that already in feet and inches? No, it is not. Might seem like an obvious question, but this is the mechanic that you want to kind of go through. Basic strategy. Ask yourself, do we have what we need? Oh, we don't. We only have inches. So then it looks like the goal is figuring out how to turn 83 inches into feet and inches. That's what it sounds like we're trying to do. Now, what does this look like, everybody? If we're trying to go from inches to feet and inches, can anybody tell me what that sounds like to you based off of your notes? What does it sound like we're trying to, do here? Oh, now I see a lot of folks saying divide, and I see a couple of other folks saying small to big. Yes, right on. When you take a look here, you're trying to go from inches to feet and inches. Really just want to focus here on the feet. And you think, hey, when I compare inches and feet, which one is the smaller one? And you can absolutely say inches. Inches is smaller than feet. And if you take a look at your notes, booyah, we have division. When we are going from a small unit to a big unit, we will divide. Now, this is going to be the first time that we're doing it in today's class, working with a remainder, and I'm going to gracefully show you how we take care of that. So with that, everybody, what's the number that we're going to be dividing by? Because I see the word division there. Sure, I wrote it down. I got that right. But you have to remember your conversion rate, and that is 12. Correct. So let's bring it all together here. We know that 1 foot equals 12 inches, and so this is what we're going to be dividing by 12. So let me go ahead and zoom on in over here, and let's divide right here, 83 by 12. Let me show you that right there. Boom. And then 83. Here's how we're going to do this when it comes to unit conversions. Everybody, first question, how many times does 12 go into 83? Right, that's going to be 6. Because, everybody help me out, 6 times 12 is what? 6 times 12 is what? 72, correct. So let's write that down. We're going to have 6 as the quotient because 12 goes into 83 6 times. 6 times 12 is 72, so that's what we're going to subtract. Everybody, 83 minus 72 gives me what? Yeah, that's going to be 11. So just pause right there and take a look. We have 11 left. Quick question, my party people. What do we call that number that's left over at the end of long division? Give me that R word again. Yeah, that's the remainder. That is the remainder. And guess what, everybody? That is going to be the remaining number of inches. Remember, we started from inches. We're trying to see how many groups of 12 fit into 83. And we have 6 groups. So that's 6 feet that we can make. The 11 that's remaining, that is the remaining number of inches. And so with that said, the final answer is going to be 6 feet and 11 remaining inches. If I had 12, that's a whole nother foot. That would have been 7 feet. But here, we don't have a full 12 inches. We have less than that. So that remains as a leftover number of inches. Our correct answer here is going to be 6 feet, 11 inches, and we are all done. Let me zoom on out. That's the problem right there. Correct answer is A. And there we go. So my party people, for anybody here who was nervous about using that technique, small to big, big to small, how do you feel about this? Does it feel like this is a technique that would serve you well as we get into bigger problems? Good. That's what I'm looking for there. Again, we have to build confidence in small, doable steps because remember, it's always impossible before it's possible. It's always possible before we're good at it. And then we're always good at it before we're great at it. So we have got to take it little by little. And again, yeah, I know we want to work towards that timer side. I know for sure. But we have got to give ourselves the time and patience to get it right before we get it quick. So give yourself that time. So what I'll do here is I'll take a quick pause, go ahead, write down what you need to write down, and then we're moving forward to the next practice problem. All right, so in this next question, we're gonna, as always, read that question sentence first. And, as I'm reading through, I realize that we're given a triple ratio, which is gonna fall under proportions, ratios and proportions. So my biggest piece of advice for that is we're gonna try to base the proportion we make. We're gonna try to base it off of this question sentence, this right here. They say that if we have 10 science students, how many math students are there? So one more time, 10 science, how many math? So again, if I'm writing that out, that comparison that I'm trying to make, I have science and math being compared. So that's all I care about. That's really what I'm going to try to do. So let me just separate this and then let's go ahead and write this out. Blank equals blank. That's what a proportion is. One fraction being equal to another. So here we are told that we have 10 science, so I'll put 10 for science, and then I'll put M for math. Up next, that right there is my goal. I'm just trying to compare, right over here, science, and then down here, I want to plug in the number that represents math. Not total, not difference, not literature, but again, science and math. That's what it's all about. So here we go. From the ratio that we're given here, everyone, where they say the ratio of math students to science students to literature students here, when we see that ratio, which number represents science? Yeah, we see that right there in green, right? Science, that middle number, boom, that is 5. And then in the denominator, what are we going to have for math? We see that the first value in purple was math, and the first value there is 3. Booyah, there we go. Now that we're here, we're all set, everybody. If we wanted to do the classic cross multiply and divide, we can. M times 5 is 5M. 10 times 3 is 30. And then we can easily divide by 5 on both sides. And that'll give us the final answer right then and there. Cancels out, and we get M equals 6. And that's what leaves us with answer choice B. There we go.